Welcome to Coach Taylor's Class Notes, and today we're going to talk about segment partitioning, or how to partition a segment. And so segment partitioning means to divide or separate. So we can partition a line segment into smaller segments and compare their lengths as a ratio. And so if we're looking at this first example here, we have line AB. And if we were to partition it into 5 congruent parts, so they went ahead and took the line, divided it into 5 congruent. Remember, we mark congruent with a line, and so all 5 of those sections are equal. So we talk about partitioning segments 2 different ways, and it's important to understand the difference. So one way that we talk about it is we talk about it in our part to part. So if we're looking at line AB, we're talking about part AP compared to part PB. And so in that case, if we're looking at AP compared to PB, AP would be 3 to 2. So AP is 3 segments or 3 partitions, where PB is only 2. The other way that we talk about it is we talk about it as part to whole. And so if we're talking about it part to whole, we're going to look at just AP compared to the whole line segment. And so when we're looking at AP, the part that we want to partition compared to the whole line segment, we write it as a fraction. It is 3 out of the entire 5. So again, if it's part to part, we write it as a ratio. If it is part to whole, we write it as a fraction. And that's going to be a very important concept to remember when we start looking at the notes. The other thing that we need to know is you need to know we have 2 formulas. It's the same formula, but we need to use it twice. Once for X, and then we need to use it once for Y. So again, it's the same thing. We just need to plug in different numbers for it. We're going to talk about that on the notes. So the first thing that I'm going to do is I'm going to look at problem 1, and we'll kind of go over the steps as we look at problem 1. So for Y, we know that Y is up and down. So I'm going to pay attention to what we call the rise of this line. Whereas if I'm looking at X, I'm paying attention to the run or the left and right movement of this line. So the first thing that we need to know is we need to know our points. It's kind of hard to tell, but that is our origin. So A's coordinates are -5, -1. B's coordinates are -7, 7. And so for me, again, X1 is always going to be the point on the left, X1, Y1, whereas X2 is always going to be the point on the right. So X1, Y1, X2, Y2. And that's the way that I personally do it. So now the next thing that we need to understand once we know these points is we need to know the rise and we need to know the run. So we said earlier that the rise is our Y value. So we need to see how much it goes up from A to B. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 is the rise, and now we need to find the run. Run is the X value, because again, it's the X-axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is going to be our run. So now what we're going to do is we're going to go back and we're going to look at those 2 formulas that I highlighted at the top. So we need we need to do one more thing first. We actually need to read the question. So they gave us A, B below. We need to find the coordinates of P such that the ratio of AP to PB. So because P is repeated twice, I know that this is part to part. So I know that AP is 1 and PB is 3. So for me to change the 1 to 3 into a fraction instead of a ratio, I need to add the 2 parts together. I know that AP is 1. And I know that once I've added the two parts together, AP is 1/4 of the entire line. So now we can go and we can look at our equations. So X, if we need to find X, we need to go X equals, so part to whole, which is our 1/4, times the run. We said the run is 12, plus our x1 coordinate. So that's where we're going to go back and we're going to look here. We said the first point on the left was our x1. So instead of plus, because the 5 is a negative, it's going to be -5, not +5. And so real quick, let's talk about fraction math real quick. I'm going to do this fraction math over to the side here. So if I have 1/4 and I'm multiplying it by the whole number 12, I can represent the whole number 12 as a number over 1. So when I multiply fractions, I multiply across. So we're going to get 12 over 4. I know that 12 divided by 4 is 3. So 1/4 times 12, x is going to equal 3 minus 5. And then my final answer is that x is going to equal -2. So that is my x coordinate. And now it's time to look at my y coordinate. So for my y coordinate, it's going to be y equals our part to whole, which is 1/4. Our rise is 8. And then our y value is a -1, so we're going to go -1. So what this tells me to do is, again, I need to go 1/4 times 8. So again, 1/4. I turn 8 into a whole number by 8 over 1. 1 times 8 is 8. 4 times 1 is 4. 8 divided by 4 is 2. So y equals 2 minus 1. So y is going to equal 1. So now what I need to do is I need to put these 2 points together into a coordinate point. So -2, 1 should be point P. And then I always check by graphing it on the line. Is this actually a point that exists on the line? So I'm going to go to -2, 1, and this is where point P would be. That's where 1/4 of the line is. And so that's how we partition a segment. So let's look at one more example because there's one more little wrinkle that this next one throws at us. So again, I'm going to highlight the rise and the run of this line. I always go from left to right, and I'm always, depending on the slope of the line, if it's negative, I'm going to count down. If it's positive, I'm going to count up first. So I'm going to highlight my run because, again, my run is my x value, and then I'm going to highlight my rise, which is my y value. So rise equals y. And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, just like if we were counting slope, if I'm counting down my y axis, I'm going negative. So if it's a negative slope, my y value is going to be a negative number. My run is always going to be a positive number because I'm always going to count left to right to make that number positive. 6, 7, 8. So 8 is my run or my x. And so now I need to read the problem to figure out my fraction, my part to whole. Find the coordinates of k, such as the ratio of jk to kl. Again, because k is listed twice, that tells me that this is part to part. So k is going to be 7 of the ways through, and then I need to add the parts together, which is 8. So k is going to be 7/8 of the way down the line. So now I can set up my equations. So x is going to equal my part to whole, which is 7 over 8, times the run. We said the run is 8, and then we said minus or plus my x1 value. So again, I said x1 is always going to be the point to the left. So in this case, this is origin, 3, 4, 5, 6. So -6, -6, comma 5. So my x value is -6, so I'm going to end up subtracting 6. So again, just a little bit of fraction math. So 7/8 times 8/1. So real quick, remember, if we have the same number on top of a fraction as we have on the bottom of the fraction, they cancel out, they go away. So I'm left with 7/1, which simply equals 7. So x is going to equal 7. Oh, come on, pencil. 7 minus 6. So x is going to equal 1. And now it's time for us to do our y value. So y is equal to the part to whole, which we said was 7/8, times the rise, which we said was -10. And then it's a +5, so I'm going to put +5 at the end. And again, let's do a little bit of fraction math. So 7/8 times a -10, and we turn any whole number into a fraction by putting it over 1. So I end up with a -70/8. I need to simplify this as best as possible. So the way I'm going to simplify it, I know I can divide both numbers by 2. So we get a -35 divided by 4. 35 I can divide by 7 or 5. But I cannot divide it by 4 and I cannot divide it by 2. So that's as simple as that is going to get. So y equals a -35/4 plus 5. So now let's remember a little bit more fraction math. So if I have a whole number and I need to add it to a fraction, what I'm going to end up doing is I have to take that whole number and turn it into a fraction, which means I'm going to take 5 and I'm going to multiply it times 4. So 5 times 4 is 20, and so 20/4 is the same thing as 5. So now I'm going to rewrite this problem as y equals a -35/4 plus 20/4. And so a -35 plus 20 is a -15 all over 4. And I know that 15 divided by 4 is almost 4. So I believe it is a 3.75, if that's easier for you to comprehend. But we got to remember that it is negative. Because again, 4 divided by 12 is 3. I'm left with 3 left over. 3/4 is 0.75. So my final point for where k should be on this line should be 1, -3.75 is what point k should be. So let's check it on our graph. So if I go to the right one, down 1, 2, 3, and yep, that looks like about 0.75. And so that would be point k, and that would be the result of our segment partitioning.